Welcome everyone to Bratati Science class. I am Bratati and let's start today's topic. Force and laws of motion, class 9.
So let's write chapter 8, force and laws of motion, class 9 science. Okay, so here a quick recap of what we have learned in the previous chapter, that we were talking about rest and motion. So this is not motion. I am standing in one position and moving my body. This is not motion. When I am rest, that means any object is at rest when with respect to time when it is compared to some another object which is called origin. This marker is at rest. I can see it at rest. I am standing at rest. But if I am sitting in a car, according to me, I am moving with the car. So I will feel that I am at rest. I am sitting in the car. So I am at rest. But the people who are looking from the outside, they can see that yes, I am moving. So I am not in rest. I am not at rest. Rather I am in motion. Again, like for example, you can see me that I'm standing, so I am at rest because I'm not changing my position. But if you go outside in the space, okay, then from the space you see the whole earth is actually revolving around the sun. So obviously I am not at rest, rather I am changing my position. I am revolving around it, so I'm in motion. So basically what we have learned, the rest and the motion, the main difference between these two was change in position. So rest is no change in position with respect to time. Okay, it is relative to time. It's related to another person or object's view. So there must be an origin with respect to the people standing in the earth. This object is at rest. Motion is change in position with respect to time. With respect to time. This is motion. So now from place A, I am lifting my leg and moving to place B. Or I am just walking through from place A to place B. This is I am changing my position. So I am in motion. Okay. Don't confuse motion and the movement. So this is done. Now the question is, what is that external thing or internal thing which causes an object to move from rest to motion or vice versa? रेस्ट से मोशन एंड मोशन से रेस्ट, ये किसकी वजह से हो रहा है? व्हाट कॉजेस दिस? सो देयर कम्स फोर्स. रेस्ट टू मोशन इज कॉज्ड बाय फोर्स. In class 8 we have learned about what is force. This is vice versa, rest to motion or motion to force caused by force. What is force? The push or pull. You remember in class 8, force is a push or a pull of an object, okay, which may cause the change in speed. See, it was at rest, again with respect to time, and I'm pushing it. It's now in motion, and it up to certain distance it will go, and again it will stop, because again of the opposite direction force is acting on it to make it stop. Clear? So that is force. What is force? The force is a push or pull that can, number one, change the speed of any object. Change speed. The problem is with the liquid. Change in speed, change in direction of an object, change in shape of an object, shape and we can also call size. Shape and size of an object. Change in speed, change in direction, change in shape and size. What else? It can change an object from rest to motion or motion to rest, vice versa. So these are the things that are done by external force, that is from outside. A push or pull on a particular object keeps it to change its initial position from rest to motion or vice versa. And similarly, like if I take a clay and with the clay molding, you know, I can mold it. I'm using my muscular pressure, I'm using my muscular force on it, and then it will change and I will make a beautiful Ganesha idol, right? So clay molding, I'm changing the shape, and I will take a bat, a super sixer. So that means a ball was coming from one direction, from the bowler side, and then the batsman can make a 6 or 4 and boundary and the change in the direction of the ball. Or you can even kick a football. So that will change its direction. So we can do direction, and our car, you know, whenever we can click on the accelerator button, then the car increases its speed. So these all can happen with the help of force. The force can be push or pull. Till this is clear. How to calculate force? How much force is needed to move an object? That comes now the topic. Now force, the unit of the force can the SI unit of the force and the CGS unit of the force. The SI unit is Newton and the CGS unit is dyne, and the conversion, like we can say 1 Newton equals to 10 to the power 5 dyne, which is required for solving the sums. 1 Newton equals to 10 to the power 5 dyne. Remember this for any solve. Force of 10 Newton is applied to an object. Convert this force to dyne. So 10 Newton equals to 10 into 10 to the power 5 dyne. This is the conversion. Okay. So which force or how much force is required for an object to change its position from rest to motion or vice versa? For that we need two kinds of force. One is balanced force. Okay, so one is balanced force. I am applying, this is at the rest, okay, with respect to the time it is at the rest. I am applying force to it, okay, and this force is that much that is not moving this object. That means here F1, suppose I am applying F1, which is nullified or equal to this force that is coming from the opposite side of the box. Suppose this is my F2 and this is my F1. These both are equal and opposite in direction, and that's why this object, the pencil box, is not moving at all. In case my F1 is more than F2, now let's see, F1 is more. So now see, it starts moving. So when the two forces are equal and opposite to each other, this is called balanced force, which will not change the direction, movement, position of an object. If it is at rest, it will be at rest. If it is in the motion, like uniform motion, it will be in the uniform motion until some external force will stop it. Okay, so balanced force, what we have understood, balanced force is the no motion, actually it is at rest or in the uniform motion. So net velocity is 0. If the velocity is 0, net acceleration is also 0. And this is the balanced force will make an object to be at their position. And the balanced force is the reason behind inertia. This term we will talk about what is inertia. Okay. So next is Inertia. What is inertia? I will tell you. So balanced force is clear. The reason behind to make an object in their initial state. If it is at rest, it will be at rest. If it is in a motion, it will be at motion. Now coming to the unbalanced force. Unbalanced force I show you. Unbalanced force is one of the force is more than the other. So this is the object A. Here I am applying force 1. Here I am applying force 2. In case here also we have B object F1 and here F2. Balanced force means F1 equals to F2. So there is no movement of B. Here either F1 is greater than F2 or F1 is less than F2, then it is called unbalanced force. In the unbalanced force, a velocity and acceleration can never be zero. Okay, so velocity we know it is it is meter second and this is meter per second square acceleration. So this will be never zero because it is in motion, it's moving. So this is the unbalanced force which causes the change in inertia. So here I will write only one point. It is the unbalanced force which causes the change in inertia. Okay, so balanced force and unbalanced force is done. Let's come to the scientist like Galileo. What is his view on what is analysis of motion? Okay, according to Galileo Galilei, what is the analysis of motion? Galileo Galilei, analysis of motion. So what he said take two slope. This is the plane. In the plane you keep two slope with an angle, similar angle. And here you at a certain distance, this is the distance you put one marble ball. Then what it will do, it is at rest. You are holding this, it is at rest and you are leaving it. So it will come here with a speed and it will not stop here. Rather, it will be again move here and to the same distance, till this point and there it will stop. When the two slopes of equal angle, then we can see the height is equal. These two marbles will go, the marble will achieve the same height like the initial one. This is the initial stage I, and this is the final stage of the marble. Okay, the height they will achieve is same. Now second case, he is telling, okay, I will change the angle. So when he changes the angle and now the angle is like this. So even then he has seen once the marble move, it will go till this height. It will go this side and it will reach the same height. Maybe from here it will achieve more. Or again changing the angle, it will be straight line. See, now I have reduced the angle, but it will achieve the same height till this it will reach. See, every time the distance is more, the distance can be changed. I mean the height is always same. The height till which the marble travels is same. Now if there is no slope at all, if it is a straight line, there is a slope and it is a straight line. Then what happens, here is the marble. It will come down and it will start moving forward without any stopping force. Any external force that is stopping it, it will try to achieve the height. But it is a straight line, so it will continue. So that was the analysis by Galileo Galilei on motion. Did you understand? that any object will try to attain the same height when they are in the motion. So in the slope they have done it. So initial height and the final height will be same, and this is what Galileo has seen. Now Isaac Newton, we all know that he has the invention of the laws of the motion, and he also discovered the gravitational force, which we'll be learning in the next chapter. So here we see what Newton has said, that he wants to talk about what are can be the laws of motion. So before moving to that, a very important point that we told to discuss, that is inertia. The inertia is any position, a state of an object, whether I am at inertia. So I am standing at the rest. I want to be at rest. This is the human nature also, or any animal instinct. Like we want to be rigid. We want to be firm in whatever we believe, whatever we see, whatever we think. And easily we don't change our mind. Okay. We can be flexible, but most of the time we want to be rigid to our decision, isn't it? Similarly, the objects want to be in their state, whether it's a rest or in a motion, and they do not want to change their state. That being in my position, being in my state is called inertia. This we can call it is a tendency of an object to restrict the change in position. This position can be rest or in motion, but the tendency to resist the change in position is called inertia. And Newton also said this can be the first law of motion, that an object will be at rest or in motion until an external force is applied to it. Very true. I will be at rest until I have a desire and I put my muscular force to move my legs forward. So that is, there comes the first law of motion, that is an object will remain at rest or motion, that is initial state, until an external force is applied. That means they want to maintain the inertia. Okay, they are maintaining the inertia. Now what is inertia and what it is depend on? Now see, I am standing here, this is my inertia, and what we call a child, a kid is standing here. So whose mass is more? My mass is more. So my pull, desire, everything will be more than the kid, isn't it? So that's why if we're fighting, mostly the parents win over the kids, because it depends on the mass. So compared to me, one tall, heavy weight and big person is there, undertaker is standing beside me. So obviously his mass is more. Or the Sarkata from the movie Stree 2, he is standing, who is 7 feet tall. So he is standing beside me. So obviously his mass is more, his wish is more, he can just push me away. I also don't want to move, just push me away, I will just push, I will just move. Okay, or a child or a kid, we just drag them, push or pull, we apply the force and they move. Now if I push the 7 feet tall Sarkata, so obviously he will not move easily. I have to put more and more force. Am I clear? I need to make it an unbalanced force. When I am applying some force on Sarkata, even he is also applying the opposite and equal force on me, and mostly I will be pushing, but he is not moved. So he is stick to his inertia, because this depends on the mass. Inertia we can see in many examples, in real life example, we will talk about that. So what do you understand? The inertia depends on mass. So this depends on mass of object. Which object we want to change its position, it depends on the mass of an object. Now let's see one example. The examples of inertia now we are doing. That is the tendency to remain in the same position. We are now see some real life example. Okay, I am standing in a bus. I am holding the rod. The bus was at the bus stop. So it was at rest. I am also rest. My body is at rest. I am holding this. Suddenly it starts. So when the bus starts, we move backward. Because my feet is with the bus. As the bus starts moving, my feet also in the motion, but my upper part of the body wants to be at the rest. So to balance it, it moves backward. And now see, look at my center point. It is coming in the average. So after some time again we have to make straight, and then when the bus is moving, now we are not moving here and there until it's apply a sudden brake again. So now from here we started and we are standing here. So now we are normal because the bus is moving, our body is also on move. Suddenly the next stop, the bus applies the brake, sudden brake. So our body tries to move forward, isn't it? So that means our feet was at the rest at the same time the bus stops. But what about the rest of the above of the body? The upper part of the body tries to be in the motion, so it moves forward. Am I correct? So this you can see in this experiment. Here we have a glass and there is you can take a piece of paper, okay, or a cardboard, piece of cardboard, and there is that coin. I'm putting the coin is on the top of it. So now, okay, so these are at the rest. Alright, what I will do when this is at the rest, I will try to pull this piece of paper so fast, which will cause the coin to get down at the glass. That means the coin wanted to be at rest along with this piece of paper, and as soon as swiftly I moved this paper, the coin went down. So there is also one example. This is also an example of inertia. With inertia, now inertia is clear to us. It depends on the mass. Okay, the coin, if the coin is more heavy, then its inertia is more. Compared to a 50 paise, I can take a 5 rupee coin or a 10 rupee coin. Obviously, the mass is more in 5 rupee coin or 10 rupee coin. So the inertia is also more, and it will be dropped down easily rather than a 50 paise coin. Because the 50 paise coin mass is less, it's easy to move. That's why we tell, have some gravity and increase your mass to be rigid or firm, whatever you decide, isn't it? So now with this, we are moving to Newton's second law, where the word comes as momentum. Here we will be learning, before going to the second law, a new term, what we call this as momentum. What is momentum? It depends on two things. One is mass, another thing is velocity. So momentum of any object depends on mass and velocity. So mass can be kilogram, velocity can be meter per second, or in CGS gram centimeter per second. These are the units of momentum. What is momentum? Momentum is, I am holding a gun with a bullet. Okay, so the bullet, I want to throw it and want to keep a wall is there. Okay, suppose there is a wall. This is wall. Somehow this is wall. This is my gun. And here I have a bullet. This is the bullet. Inside the bullet, and this is the gun. This is the bullet. Gun and bullet is at the rest. Gun and bullet is at the rest. Okay, so initial speed, m, this is m1, okay, and the initial speed is 0. So m1 and u, m1 u1 is at rest, and then I try to pull now trigger. I put the trigger and the bullet is out with the velocity. So velocity is changed and the bullet is now here penetrating the wall. So there will be a hole in it. So now the mass cannot be changed. The bullet mass is same but the velocity is v1 now. So this was the p1, that is the initial momentum, and this is the mass into velocity, right? So mass into velocity, this is p2, p1 and p2. This is the momentum. Now in case, suppose I don't have a gun and I have a bullet. So I am standing in front of the wall and want to throw the bullet to penetrate the wall. Is it possible? What do you think? It cannot be possible because in my bullet the mass is same but the velocity when I am throwing it's not as when I am triggering the gun. So velocity will be less. So if the velocity is less, the momentum is less, and the momentum is less, the bullet cannot penetrate the wall. So here we know that it depends on velocity is one of the important criteria. Another example, the wall is there, I am cycling to the wall and dash with it. I will fall down, I will get hurt. With the wall will have anything? No. But instead of me riding a bicycle, I am coming with a truck. A heavy loaded truck, I am coming with the same velocity. The velocity is same. I was riding the cycle with 40 meter per second and I dashed it with the wall, but the wall did not collapse. I got hurt and I fell down. Now I am coming with a truck with a 40 meter per second velocity. The velocity is same and I dash with the wall will collapse. Because here you see the velocity was same but the mass of the truck was more than that of the cycle. So as you know now from here that momentum does not only depend on velocity or on mass, but together mass and velocity will cause the momentum of any object. Clear? So with this we come to the second law of motion which deals with momentum. And this momentum is proportional to the force applied on the object. This is the second law. The second law of motion is the change in momentum is directly proportional to the applied force. So this is the second law of Newton. So mathematical derivation will be the force F is proportional to the change in momentum, that is dp by dt, delta p by delta t. So when we are solving an equation, the proportional sign, if we want to make it equation, there will be a constant k. So F equals to k into del p by del t. What is the formula for change in momentum? We can write k into m is common, isn't it? So it is like, you remember the gun and the bullet? So m1, change in momentum means m1 v1 minus m1 u1 by t. So if we take m1 common, it is v1 minus u1 by t. K is 1, where k, the constant, is equals to 1. The value of k1, so this is the mass into the mass, you can take m1, into v minus u by t is called the acceleration. You remember the change in the velocity with respect to time is the acceleration we learned in the last chapter. So this is m1 into a1, where a1 is the acceleration. So from this derivation we come to know that second law is stating that it is F equals to m into a, that is mass into acceleration. So from the second law we can derive the definition of the force as, see, this helps into the solves once again, I am telling you, because in exam suppose you have F, you have m, you have to find out the acceleration, or you have the other two things, you have to find the force. So force equals to mass of an object into the acceleration. Okay, so now let's derive some of the sums here. We can see in page number 91. Okay, here questions are there. Which of the following has more inertia? Option A is a rubber ball and stone of the same size. A rubber ball and the stone. Obviously, the mass of the stone is more, so the inertia of the stone is more. B, a bicycle and a train. Compared to bicycle, the train mass is more, so the inertia is more. A 5 rupee coin and 1 rupee coin. Absolutely correct. 5 rupee coin. A football player kicks a football to another player of his team who kicks the football towards the goal. So, how many times it changes the direction? 2 times. The goalkeeper opposite team collects the football and kicks it towards the player of his own team 3 times. Also identify the agent supplying, because every time who is applying the force is different player. Why some leaves may get detached from a tree if we vigorously shake the branch? As we are shaking the branch vigorously, we are applying force, and every time the direction of the force is being changing. That's why our leaf may get detached from the branch, because they want to remain in their state, inertia. But as every time we are changing their inertia, they are unbalanced, disbalanced. Suppose we are continuously doing this. So obviously if you are in mass is less, the one leaf mass is less, so it will fall down. Why do we fall in the forward direction when the brakes applied in a moving bus or moving vehicle? We discussed already. Now second law of motion, based on this we have mathematical formula. So here you can see the momentum P. The momentum P is equals to m into v, where m is the mass and v is the velocity. So this is the momentum. Now the derivation of the second law of motion we have done, that is F proportional to m into v minus u by t, which is k is the constant into mass into acceleration. Okay, for 1 unit force, if 1 unit force is applied for 1 kg of object 1 meter per second square, then it becomes k becomes 1, F equals to m into a. So from this we come to know that the force equals to mass into acceleration. Now there is some examples. Okay, let's see. A constant force acts on an object of mass 5 kilo. So the m is 5 kilo for a duration of 2 seconds. T is 2. It increases the object's velocity from 3 meter per second to 7 meter per second. So we know u and v, initial and the final velocity. Find the magnitude of the force, F equals to m into a. And now if the force was applied for a duration of 5 seconds, so T1 was 3, T1 was 2 seconds, T2 is 5 seconds, then what would be the final velocity of the object? So let's see. So they have given us page number 93 and we are doing example 8.1. So here it is given as the mass m equals to 5 kg, T1 2 second, T2 5 second, u the initial velocity is 3 meter per second, final velocity is equals to 7 meter per second. Alright, so find out the A equals to V minus U by T1. So we know 7 minus 3 by 2, which is 2 meter per second square. So we got our acceleration. Next questions, what will be the final velocity? So final velocity V1, because this was V. So V1 equals to initial velocity plus UFM. V equals to F we already got it. No, F equals to, yeah, this is A, and after this we got the F. They are asking that how much force, find the magnitude of the force. So we got A, but we have to find the force. The force into is equals to m into A. The mass was 5 kilo and the force is 2 meter per second. So it is, we can write 5 kilo into 2 meter per second square equals to 10 kg meter per second square or 10 Newton. So we found the force. The force is 10 Newton. Now moving to the next one. Which one we will do? We will do 8.3. A motor car is moving with a velocity of 108 km per hour, that is u. It takes 4 seconds t to stop after the brakes are applied. So it will stop means final velocity 0. Calculate the force, and when the mass along the motor car's mass is 1000 kilogram, 1000 kg. So we need to check whether all units are in the same unit or not. Like kilometer per hour, second, kilogram. So it should be meter per second. Then it will match. So first we have to convert the u to meter per second. Okay, now we are into page number 94. Page number 94, and it is 8.2. So there what we have? Initial velocity u equals to, is saying 108 kilometer per hour, 108 into 1000. 1 hour is 3600 seconds. 1 2 1 2. 4 9s are 4 27s are 9 3s are. So this is 3000 meter per second. So this is our u. 300. So this was 9. So 3 into 10. 3 into 10, 30 meter per second. This is our u. And they said that our v is 0 and t is, time taken is 4 seconds. T is 4 seconds and the mass m is 1000 kg. So how to find the force? The force F equals to m into a. Now m is 1000. A is v is 0 minus u by t is 4. So 4 and this is 250. So 250 into minus 30. So this is minus 7500 Newton. So as it is minus sign, from there we can understand the force is to the opposite direction. Motor car is moving. How much force is applied? Applied from the opposite direction, which we call as frictional force. Okay. So the force is minus 7500 Newton. Let's see this one, this graph. The velocity time graph. We have done graph also. Of a ball of mass 20 gram. So m is 20 gram moving along a straight line on a long table. So how much force does the table exert on the ball to bring it to rest? That means the v is 0. But the u is initial velocity. Here from the graph we can see this is 20 meter per second is the u, initial velocity, and the time taken is 10 seconds. So the v is 0 is given. The question is how much force? So F equals to v minus u by t. From the graph we have to find out the u, the initial velocity, and the time taken to come to the rest. This is the Vt graph. So same page number 94. Now we are in 8.5. So this graph related sum can also come. Just follow, you know how to calculate from the graph. We already did it in the last class. It can be ST graph. It can be VT graph. Right. So this is 8.5. And what is the graph? The graph is saying this side is the velocity and this side is the time taken. So in velocity we have 5, 10, 15, 20. And time taken it is 1 second, 2 second, 3 second, 4 second, 5 second, 6, 7, 8, 9, 10. This is T. This is V. Now the graph is from here to here, 0. So that means from this graph we come to know the initial velocity is 20 meter per second, the final velocity is 0 and the time taken is 10 seconds. We have to find the force. The force is, everyone, the force is m into a. Mass is given as, what is the mass? Mass of 20 gram and this is in meter per second. So what we need to do, the 20 grams do we need to convert in kilogram? So what to do? We have to divide by 1000 to make it kilogram. Into acceleration, acceleration is v0 minus u20 by t is 10. So this is 2. So 2 into minus 20 is minus 1 by 25. Write this only, minus 1 by 25 Newton. So we got it in the Newton, minus 1 by 25 Newton, right? Now we are moving to the third law of motion. Third law of motion. So second law motion derivation is done. Newton said the third law, like every action will have an equal and opposite reaction. And these two forces, action and reaction, these are the forces that are applied on a different object. Okay. So in this example, here initially we had this box. This is the box. This is F1. F1. And this is F2. So when I am applying F1 to the box is applying the similar force to this marker. So now you see when the marker is applying the force, it is towards this side. And when it is applying the force, it is towards this side. So the direction is opposite to each other. If the force is equal, it will not change its position. It will be in the rest. It will not change its position. But if it is unbalanced force, it will move. So here we see one marker is applying force to the box and second time the box is applying force to the marker. So again we know this gun and the bullet experiment, I mean the example, gun and the bullet example, what will be there? It is saying that before moving to the third law, let us explain again. So this was the gun, okay, and here inside there was a bullet. Okay, so this was the bullet. So what I am saying, that is when the trigger is being put, trigger is being applied here, then the bullet will come out and the bullet will again apply the same force so that there will be a recoiling. Again we have to set the gun and again we have to do it. So except the automatic guns are not. This is the general thing that we have to, that is one is being applied to the bullet, the gun applied to trigger applied to the bullet same amount of force will be applying to the recoiling, that is to the gun. The gun will be coming back. That means the bullet is moving and the gun is coming backward, because in the same way the bullet is also applying the force. Or when you give a slap to somebody or this, so I am applying the force and here also I get hurt, here also I get hurt, both, because my face is also applying the same force to my hand, right? We do high five. High five means one is applying and equal force is applied to this also. Same like if we punch to the wall is also applying the same force to our hand. Okay, it will not move and it will apply the same force, we get hurt. That means all the objects, whenever any action is there, there is a reaction, isn't it? If we do this, we'll get the swelling and redness. So it is reaction will have an equal opposite reaction. But the objects they are working on will be different. So according to the third law of motion, it is now we are into the third law. The third law is every action has an equal and opposite reaction. Every action has equal opposite reaction, but they act on different objects. Right? They act on different objects. So this is according to Newton's third law. Now the last thing that we are going to talk about, that is the conservation of momentum. So Newton's three laws are clear. First law is talking about inertia. Second law is talking about momentum. And third law is talking about the force equal and opposite. Okay. Now conservation of momentum. For this also we can take the example of the gun and the bullet. Okay, in the gun and bullet example, we will see the initial momentum is equals to final momentum. This is the conservation of momentum, and we know momentum Pi equals to mg ug plus mb ub. Now what are this? Mg is the mass of gun, ug is the initial velocity when they are at rest, and the mass of bullet and the initial velocity of the bullet, which is 0 because they are at rest. So v is u is 0, ug and ub is 0. So total initial momentum is 0. But final Pf equals to mg will not change, mg into vg plus mb into vb. Mg will not change, but here vg and vb, so they have, as you know, the bullet went inside and the gun recoiled back. So both of them, they have the velocity. So that is also equals to 0. How? How? Because together their momentum should be same. Because the momentum is proportional to the applied force. And the conservation of momentum is saying that when an heavy object is coming and dashing with a light object, then they change in their speed and their final momentum is equal. Okay, so that means before this we can go to the main concept of conservation of momentum, and in the main topic and the main explanations, I want to show you that there are two ball. One is ball A, another one is ball B. Ball A has mass ma and the velocity, suppose it's moving this side, the velocity is ua. Ball B has mass b, it's moving with a speed called ub. So A is mass is more, so this momentum is P1 is ma and ua, and this momentum is mb into ub. So A is going and dashing with B, and then when they are dashing, this is their condition. This is A, this is B. Now B will apply a force to A, so this is FBA, and A will apply a force to B, which is FAB. Their mass remains same, MA and MB, but the force applied is the opposite to each other, and so finally after this they are in this condition when their velocity differs. Now they have MA and MB, but their velocities are, suppose again they are moving like with VA and with VB. Those who was in more speed, UA was here, UA is more than UB. Initial speed is more, so it will dash it, and then it will increase its speed. B will increase its speed, VB, but A will decrease its speeds because together the momentum must be same. As there is no change in the mass, so the change will be only in their velocity, because together mass and velocity will make the momentum. So that is the reason their speed or velocity will change. Now A will move slowly compared to before, and B will move faster compared to before. So now their momentum is P2 is MAVA plus MBVB. So according to the laws of conservation of momentum, this P1 should be equals to P2. To make these two equal, there is no change in the masses, right? So that's the reason we have to make the change in the speed or velocity. Clear? With this, we come to the examples of the gun and the bullet. In the gun and the bullet, initial condition, the gun and bullet both were at rest. Their momentum was also initial was rest. But when the bullet is thrown and the gun is recoiled, that means the bullet changes velocity and the gun also changes velocity. So as there is no change in the momentum, P1 equals to P2. So the gun, that is MGUG, this is the initial I'm talking about, initial mg and mb, ub is 0. Okay, this is P1 and P2 is mgvg plus mbvb. That also must be 0. So according to them, mgvg equals to minus mbvb. Therefore, the velocity of the gun equals to mbvb divided by mg. mbvb is the momentum of the bullet. So this is momentum of bullet divided by the mass of gun. Then we can get the velocity of the gun recoiling back. Or we can get vice versa. We can get the velocity of the bullet also. Okay, so if the masses are known, so this is how from the conservation of momentum we can solve this problem. Now quickly we will see the exercise, children. What we have learned today what causes the object to move from rest to motion and vice versa. We have discussed Galileo's analysis on motion and Newton's 3 laws and what are their definitions. Now in the exercise, an object experiences a net zero external force. Is it possible for the object to be traveling with a non-zero velocity? If yes, state the condition that must be placed on. Now the force F equals to 0. F equals to m into A. M cannot be 0. So m into A is 0. M is not 0. So that means A should be what? A should be 0. So if acceleration is 0, so that means non-zero velocity. That means acceleration is 0 is velocity can be 0. They are at rest. When a carpet is beaten with a stick, the dust comes out of it. Explained. Now the carpet and the dust all were in the rest position. As soon as we start beating, there is a force applied and the dusts which was at the rest are now in motion. They wanted to be in the carpet but they will come out of it. Right? They want to be in the same position. So they will come out. Next, why is it advised to tie any luggage kept on the roof of a bus with a rope? Same condition, we can adjust our body forward and backward when the brakes are applied. Okay, or it starts, then the luggage may move down, fall from the bus. That's why they should be tied with a rope. A batsman hits a cricket ball which then rolls on a level ground. After covering a short distance, the ball comes to rest. The ball slows to stop because there is a force on the ball opposing the motion because of the friction that come to the rest. And this is due to the unbalanced force, obviously. So option C. A track starts from rest, U is 0, rolls down a hill with a constant acceleration, travels a distance of 400 meter, that is S to 400, T 20 second, find the acceleration, and the 1 ton is, find the force acting on it, the mass is 7 ton. So first we have to calculate the mass. 1 ton is 1000 kg, so 7th ton is 7000 kg. They are asking to find out the acceleration. A equals to V minus U by T. The V, U was 0. Acha. So travels a distance of 400 meter in 20 seconds. From here we can find the V. The V is 400 meter in 20 seconds. Then how many meters in 1 second? That is the V. So V minus U by T is 20 second. Then we can get it the acceleration. A stone of 1 kg is thrown with a velocity of 20 meter per second across a frozen surface. Okay, what is the force of friction between the stone and the ice? Alright children, the rest of the questions solved we will do in the next class. So I hope you liked today's sessions, and please stay tuned for more such updates and more such interesting videos. Alright, any part of the video if you like, please share and click the like button, and please stay with us and click the subscribe button. Thank you. Stay happy, stay healthy, enjoy learning and spread your knowledge. Bye bye.